everyone. This is Dr. Shirisha, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to discuss a few important questions that you may get in your exams, SW exams, in your second module, which is stacks, queues, circular queues, and double-ended queues and all. So let's start with a stack. Stack is nothing but a linear data structure which goes with the funda of last in, first out. That is, this is a structure where you are given a provision to insert an element or delete an element only from the one end, that is top end. Have a look at this one. I have inserted three elements. The top pointer, which holds the most recently inserted element, is going to get incremented and it's going to point to the most recently inserted element. Okay, so push and pop are the operations that we are going to perform on stack. This is an important question, guys, in exam point of view. So they'll be asking you what is a stack and what are the operations on a stack. If the question is generic in this way, please define what a stack is, on what principle it works, and show a small structure of that, including top. Top is a very important variable. Okay, coming to the operations, do mention all the five, where push and pop are the major ones. Push is to insert and pop is to delete. Peek is to return the element pointed by the top. Right? Useful is to check it, that is, useful function will return true if the stack is full, which will lay a path for overflow condition. Coming to is empty is empty is the one which goes with underflow condition. It will return true if the stack is empty. Okay, so these are the five basic operations. Coming to the applications, one of the very important questions in stacks. The first basic application of stack is evaluation of a given expression, arithmetic expressions. Humans understand infix expression, whereas system understands only postfix, which is free of brackets, right? So to convert an infix expression to postfix, whereas evaluate a postfix expression, stacks are used. Okay, backtracking, to backtrack anything, like that is, if you want to go back and check, right? That for all the purposes, wherever you need that, stacks are used. Delimiter checking, that is parenthesis. And if you are familiar with C programming or C++, you know that every open bracket must have a closing bracket. That is the starting point of compound statement and the end. It are the delimiters of any compound statement, right? So using stacks, we can check whether it is balanced or unbalanced. If you want to reverse a data, okay, if you want to work with functions, all the function calls, the return addresses are stored in a stack. Recursion, that is a function calling itself, is the best application of stacks. Whenever you get a question on applications, whether it's a stack, queue, or linked list, tree, graph, whatever it may be, please confine your answer to the course. Okay, please do not give generic answers or real life answers. Stack, like if there is a box is filled with books. If I want the last one, I have to pick the first one first. So don't give those idiotic answers. Please confine yourself to the course. Okay, so you are writing this answers for data structures subject, so please confine yourself for the same. Okay, so these are the few applications of a stack. Coming to, as I said, we go for arithmetic expressions, right? The evaluation of arithmetic is the application. So to understand that, you need to understand infix, prefix, and postfix expression. So infix is a case where operator is at the middle, prefix is operator is in the front, postfix operator is at the end. Guys, in exam point of view, they'll give you random expressions and they'll ask you to write the prefix or postfix or both. Okay, Please be careful. And we have posted which are explicitly meant for that. Follow them. So, how to convert a given infix expression to postfix using stacks? Very important question. So, if they ask you the algorithm, please provide them the same. That is, you can have in an infix expression, you can have, when you start reading the string from left to right, you can get four different cases. The first case is what if it is an operand, what if it is an operator, what if it is a left parenthesis, what if it is a right parenthesis. You have to act accordingly. And this is an algorithm for the same. If it is an operand, send it to postfix expression. If it is a left parenthesis, push it into the stack. If it is an operator, check for the precedence. If the element on top of the stack is of higher precedence, then remove it and push it to the postfix expression and insert the token in your hands into the stack. Okay. If it is right parenthesis, pop the elements from the stack and send them to postfix unless you encounter a left parenthesis, right? If you finally, when you encounter a left parenthesis, pop it, right? So as you understand, I'm using the terms push and pop, right? So a stack is used. This is the algorithm. If they ask you the algorithm, please mention. If they ask you to explain infix to postfix conversion algorithm with an example, please take an example. So here is an example which I have taken. So the table will have three: symbol, stack, and postfix external. Three columns it is going to have. Consider each and every token which is passed to it. So A is an operand, send it to postfix expression. Multiplication is an operator, push it into the stack. Next is left parenthesis, push it into the stack. Next is B, send it to postfix. Next plus operator, so push it into the stack. Always compare with the element which is on the top. On top you have left parenthesis. It is not having any problem while inserting plus. So insert, push it. Next is again a left parenthesis, push it. Next C, it is an operand, send it to postfix expression. So the next is a plus, push it into the stack. And again an operand, send it to postfix expression. A closing bracket will tell you that pop the elements, which is plus is popped and sent unless you encounter a left parenthesis. Once you encounter a left parenthesis, go with the next one. Next is star, which is an operator. On top of the stack is plus. Plus is inferior. It is having less precedence when compared to star. So you can easily insert it. Not a problem. Next, left parenthesis, push it into the stack. E, send it to postfix. Plus push. F, send it to postfix. Then a closing parenthesis, that is the right parenthesis, pop. Only plus will be popped, and a left parenthesis is encountered, just pop it. Do not send it anywhere. It is of waste map. Now division. As division on top of the stack, you have multiplication. Division and the multiplication share same precedence. So star will not allow slash to sit on its head. So multiplication is sent to postfix expression first, and then slash is inserted. Okay, now G, send it to postfix, closed parenthesis, pop, slash, and plus. Okay, guys, you need to look at the order. First, you have popped slash, so it will come first, and then addition, it will come next. Okay, right? Please follow the order. Order is the main heart of these expressions. Next is your H, send it to postfix expression, end of the string. So once you reach the end of the string, pop all the elements present in your stack. The element present in your stack is star, send it to postfix. So this is the final postfix expression that you get out of the given infix expression. Okay, once the postfix expression is in your hands, you have to evaluate it to get the result. Okay, so when this is a small algorithm for the same, so where you have postfix expression in your hands, maximum it have only two types of cases. Either the token can be an operator or an operand. Okay, so how we are going to do that? So for example, take an example. So it is having 5 columns now: symbol, stack, operand 1, operand 2, and the result. So the first one is 5. Whenever you encounter an operand, push it into the stack. So 3 and 2 are pushed. Whenever you encounter an operator, pop 2 elements from the stack, perform the operation, push the resultant into the stack. So I have popped, have a look. First pop is 2, operand 2. Second pop is 3, operand 1. So 2 into 3, 3 multiplication is the operator which is encountered, right? So 2, 3, 6. Push the result into the stack. So these are the steps we have to do. Very simple algorithm. Okay, next is plus. As you have encountered plus, again pop. Top element will be operand 2. Its next element will be operand 1. Perform addition. Push the result into the stack. Okay, so this is how a given postfix expression will be evaluated. Next is 4. Push. Next, subtraction. Subtract 11 minus 4, which is 7. Push it into the stack. Next is an operand 5. Push it into the stack. Next is addition. Pop 2 elements. Perform addition. Push the result. So end of the postfix expression, and there is only one element in this stack, which is 12. So it is a perfect evaluation, and the result of the postfix expression is 12. Okay, so these are the two major steps in evaluating an expression, given infix expression. Yes, read the question properly, what they are asking for. If they ask you, give the procedure to evaluate infix expression using stacks, then you have to write 2 steps. Step 1 is infix to postfix, then evaluate postfix. Second question can be evaluate postfix expression. They have right away given postfix. Just explain that one step, that is enough. Please read the question properly, what they have asked it for. Many I have seen, they get confused or they overlook that what expression they are asking for, right? So if the question they give with a string, then please draw a table. Guys, to answer this question, you have to draw the table. It is mandate. Okay, so in the scheme of evaluation, marks will be allocated for this table also. Okay, if you want to enhance your answer, you can always write a remarks column also, and you can, within few words, you can explain what is the operation you have done. Even that you can do. Okay, that is optional. Okay, majorly what you are going to do, you have to show. Okay, in the tabular form. Okay, next linear data structure is queues. Queues follows first in, first out. The element which enters first will be removed first, right? So the basic operations are enqueue to insert an element, dequeue to delete an element, isFull to check whether the queue is full or not, empty to check whether it is empty or not. Front and rear are the two functions to return the element present at the front and rear ends respectively. Okay, so let's have a look at the operations on a queue. Initially, when you implement a queue with an array, okay, the front and rear will be pointing to -1. These are the initial default values of front and rear. As when you work with the stack, the default value of top is -1, right? So similarly, here we have 2 pointers, front and rear. So their default values will be -1 initially. So when you insert an element, both front and rear will be incremented because it is the first element in the queue. So hereafter, if you insert an element, only rear will be incremented, not front. Okay, see, 15 only rare is incremented. 21 only rare is incremented. Next 11 rare is incremented. 7 rare is incremented. One more element 14 rare is incremented. Right? So if you try to insert an element here as the rare is pointing to the highest index, it will say that overflow has occurred. Why? Because rare is the direction in which we have to insert the data in a queue. If it is pointing to its highest index and which cannot be further incremented, then that itself says that if you insert, it will go overflow, it will go in waste. So this is overflow condition. Okay, so now let's perform DQ. So by incrementing the front, you are going to remove the elements. That is, you perform DQ operation. So again increment to 15, you lost 15. Again increment, you lose 21. Again DQ, you lose 11. Again a DQ, you lose 7. Again a DQ. As have a look at this specific case. Here you can see that front and rear are at the same position. Guys, there will be a question, tricky questions if they ask. They'll ask you when, explain the scenarios when rear will be equal to front. Scenarios. So guys, there will be two scenarios. Okay, the first scenario where the queue is empty. When the queue is empty, both front and rear will be having a value -1. If the queue, and the second case is only one element in queue. If there is only one element, both front and rear will be pointing to that one. Okay, so we cannot specify at what index value. We never know, right? So if only one element is present, front and rear will be pointing to the same index, or if the queue is empty. So here you can see a scenario. There is only one element in the queue. So front and rear are pointing to only that element. So what will happen if you remove that? Both will get their initial default values, which is -1. Now you can say that the queue is empty. What will happen if you again try to remove? That is to, you want to perform a DQ operation. Removing an element from an empty queue is of no point, right? It is waste. So it is underflow condition will raise. So a case where front and the rear both are pointing to -1, we call that as underflow condition if you try to perform a DQ operation. Okay, so advantages and disadvantages of a linear queue is very important question. Just like advantages, applications of stacks, advantages and disadvantages of queues, linear queues is very important. Advantage is it takes heterogeneous data and it can be extended to any length. Okay, so if you work with the linked list. The major disadvantage is, have a look at this picture. Okay, I have inserted all the full size elements. So my rear is pointing to the last and I have deleted 3 elements. Okay, my front is pointing to index value 3. If I try to perform an NQ operation now, what will happen? So the only condition with linear queue is if rear is pointing to higher index, I cannot insert. Yes, the condition satisfies. But have a look at the queue. The first 3 positions are vacant. Even though you have empty space, you cannot insert an element into your queue. That is a major disadvantage of linear queues. You have to mention it with a diagram. Yes, please take the help of diagrams in case of data structures to explain your words. Okay, a picture talks 100 words. So if you draw this one and write 2 lines, it will suffice. Right? So this is the disadvantage of linear queues, which you can overcome. Okay, using circular and double-ended queues. Let's see. Before going to that, applications of queues, very, very important question. So applications of queues is resource sharing with multiple consumers, right? So sharing like CPU scheduling, disk scheduling, CPU, disk, all are resources, right, for a system. So sharing them is one of the applications of queues. Next is a asynchronous data transfer. That is, if the source speed is very high when compared to destination, and while communicating, source is sending the packets very fast, and destination is not able to receive them or process them with such a speed, it will maintain a buffer, and the buffer is built using queues, right? Next is handling of interrupts, right? So these are the few applications of queues. As I said, confine yourself to the course while writing the applications, right? Right. Don't give that in the queue while collecting the movie tickets. I'm the first person, so I'll get the ticket first. Please don't give those idiotic answers. Okay. So the drawback of linear queues you are going to overcome using circular queues. So circular queue is nothing but a queue where the last element and the first element are linked, right? So if you try to insert an element, for example, you have inserted an element in the 5th, 6th and 7th. Now your rear is pointing to the highest index, and you have deleted two elements, 10 and 20. Now your front is pointing to index 2. If you try to insert, it will check whether the 0th index is empty or not. How? Check f is not equal to 0. If this condition is true, then make r point to 0 and insert the element. Okay, very simple. A of r is equal to the item which you want to insert. A simple piece of code. Okay, this is the advantage of circular queues. You can rotate around. Okay, so the basic operations are the same, and circular queues are used for memory management, scheduling, and traffic systems, right? So traffic, red, blue, green, right? They circularly change the colors. It is one of the applications of circular queues. Next, let's work with circular queues with an animation. If they ask you to give a demonstration on working of circular queues, please draw it and explain. If you insert, circular queue is a queue basically. So if the queue is empty and you're inserting the first element, front and rear will be incremented. Okay, so I have inserted one more element, four more elements, fine. Then if I try to insert, definitely overflow. Overflow condition have a condition added. Previously, we had only when rear is pointing to n minus 1. Here, as this queue is circular in nature, I have to check whether f is equal to 0 or not. If f is pointing to the 0th index and rear is pointing to the last index, then I can say that the queue is empty and NQ will raise overflow condition. Okay, so if I DQ 3 times, so 6, 12, 11 are deleted, and my front is pointing to 7. Okay, so if I try to NQ now, as I said, rear will check whether the 0th index is empty or not. As it is empty, rear will be pointing to 0th index now, and 71 is inserted. Two more insertions, very good. What if I try to insert one more element? Overflow. And the condition for that is if f is equal to r plus 1. It is an overflow condition. So cumulatively we have two conditions where we cannot perform in queue. The first one is we have the front is pointing to rear plus 1, or you can have front is equal to 0 and rear is equal to n minus 1. So if either one of the conditions prevail, we can say that we cannot insert. That is overflow condition. Okay, so the drawback with, I cannot say drawback, the working of queues is the linear queue or circular queue in such a way that the restriction is there. That is insert at the rear end, delete at the front end. So if you want to extend the wings of it, double-ended queues come to the picture. What they say is from the rear end you can delete, and at the rear front end you can insert. Extending the wings of a queue you can perform this double-ended queues, right? So it is also known as head tail linked list. So in exam point of view, you'll get a question like queues versus double-ended queues, or it is also known as DQ. The famous one is DQ. Okay, so this giving this privilege itself is the major difference between these two. Okay, this is how it is going to look like, guys. Okay, at the rear end you can perform insertion and deletion, and at the front end also deletion and insertion. You'll get a list of operations now. So insertion, two cases, rear and front. Deletion, rear and front. So get the element or return the element pointed at the front and right. Check whether it is full or empty. These are the list of operations that we perform on double-ended queues. So there are two types of double-ended queues. They are again split mindias. So what is the input? First one is input restricted queue. So what it says is the basic property of the front is deletion. The extra privilege that we have given is insertion. If you revoke that, it is known as input restricted. Coming to output restricted queue. At the rear end, its purpose is insertion. The extra feature that we have added is deletion. If you revoke that, it is output restricted DQ. Okay, so if they ask you type what is DQ and what are the different types of DQ, pictorially represent what a DQ is, how it looks like, how it is different from a linear queue, and then with the help of pictures, explain the types of DQs, right? Because as I repeatedly I'm saying, data structures need pictures. Draw it properly. If you are working with arrays, mention their index values. If you are working with linked list, mention the addresses. Then only you can show some impact on the person who is going to correct your papers. Okay, so with this, I'd like to conclude. If you want to go deep into each and every category, what a stack is, what are its operations, how push and pop are done, everything. Queues, NQ, DQ, in circular and double-ended queues also, how insertion and deletions will be done. Everything is detailedly covered in your lecture videos. Please follow the channel. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.